Any others? So you all got one? Okay, let's go through it. So f of 1, there's many different ways to do this. I just go ahead and say, okay, I'm going to do f of 1 first. I'm going to calculate the inside. So that would be 1 squared minus 3. So we would have 1 minus 3. So we would have negative 2. Am I correct so far? So really what we're doing is f of negative 2. So we're doing it again. So f of negative 2, we're substituting in that for x. Negative 2 squared minus 3. Well, yeah, good job, guys. Negative 2 squared is positive 4 minus 3, which is 1. Way to go. Awesome job. You guys are awesome. Okay, let's get to today's lesson so that we can hopefully have no homework. So today we're starting Unit 5, and we're going to be dealing with inequalities. So today we're going to be solving inequalities. So first of all, what's an inequality? I'm about to tell you. Really, an inequality is just a fancy equation. It's an equation that doesn't have an equal sign, but instead has an inequality. So once again, don't let the word inequality scare you. We all know how to solve an equation. The only difference is it's not going to have an equal sign. It's going to have one of these signs. So this is greater than or equal to, less than or equal to. Now remember, greater than always eats the bigger thing. Like alligators would rather eat something big than small. Just a way to remember greater than. So it always eats the big thing. So this is just an example, guys, of an inequality. 2x minus 1 is greater than 3. Now notice it doesn't look a whole lot different than 2x minus 1 is equal to 3. Does everybody see how they look almost exactly the same? Well, you're going to treat them the same pretty much. You're going to solve for x. It's just this one has an inequality, so you just got to be careful of a few things. So it's just a fancy equal sign. Okay, so phrases like at most or at least suggest a relationship which two quantities may not be equal. So it might not be equal if it says at least or at most, and that's often when you know you're going to be using an inequality. So once again, we already talked about this. X is greater than 4. It eats the bigger thing. That's why it's greater than 4. And if we were to graph that on a number line, so here's our number line. If we were to graph that solution, X is greater than 4, then notice since it's not equal to, we have an open circle. So look, it literally just makes sense. It makes sense. It's exactly how it says. These are the X values greater than 4. Am I true? Do you see that? It's pointing in the direction for X values greater than 4. If we had a closed circle, that means it lands on 4. And so it's equal to 4. So right here, so we just did this one. Now we're doing greater than or equal to 4. Once again, these are the x values that are greater than 4, but because it's or equal to, it lands right on 4 because of closed circle. X is less than 4. So literally it makes sense, guys. These are the x values, less than 4, and it's an open circle because it doesn't touch down at 4. It's just less than 4, not equal to 4. So we have an open circle. Less than or equal to 4, you're getting the gist here. Are we all good with how to do this? Questions? No questions? Are you sure? Okay. Okay, this is probably one of the harder things, but it shouldn't be hopefully after today's super hard. One of the harder things for students to do at a lower level of math, because your brains can't quite, a lot of times your brains can't quite think on such an advanced level. This isn't super advanced, but you do have to kind of think about it. So here's, we're going to be writing an inequality from a sentence, and you have to look at keywords and kind of use your logic to come up with these sentences. So it says, everybody look up here. What inequality represents the sentence 5 fewer than a number is at least 12. Once again, 5 fewer than a number is at least 12. So with these guys, it's hard to not work backwards. It's way harder if you do not work backwards. So I always work backwards. I say, so 5 fewer than a number is at least 12. Then a number. Do we have any idea what that number is? No, so that's where I start. I say, okay, I have a number x. Is everybody good with that? I have a number x. And 5 fewer than that number, so 5 fewer would be taking that amount and subtracting 5, right? Is everybody comfortable so far? So 5 fewer than a number is at least 12. So is that greater than 12? Yeah? At least 12. Think about it. If you have at least $12,
Wouldn't that be like less than or equal to?
at least 12. So the least amount is 12, right?
Greater than.
Right. Greater than or equal to. Very good. So greater than or equal to 12. Now think about it in the real world. If you have at least $12, then you have either $12 or more, correct? If you have at least $12, you have $12 or more. So does everybody understand why it's greater than or equal to? Then from here, well, that's all we have to do. Set up an inequality that represents the sentence. Are we all comfortable with that one? Okay. One more. What inequality represents this sentence? The quotient of a number and 3 is no more than 5. So the quotient of a number and 3 is no more than 15. Sorry. It's no more than 15. So I always start with, okay, I have a number, don't know what that is. So it says the quotient of that number and 3. Quotient means division. So that number divided by 3, it says is no more than 15. So it's less than. If you have no more than $15, you have less than or equal to $15. So less than or equal to 15. Is everybody comfortable in how I set up that inequality? Now I could solve it. I'm not asking you to do that. As long as you can set up a correct inequality. Are we all comfortable so far? Do I need to do more? Or are we all okay? Do you feel like you're ready to try it on your own? Okay. Do 1 through 4. Ready, set, go. Okay guys, everybody, here we go. So the solutions of an inequality are the numbers that make it true. Once again, the solutions of an inequality are the numbers that make the inequality a true statement. The properties you use for solving inequalities are similar to the property used for solving equations, and we're getting better at solving equations. We kind of came in a little bit rusty, but hopefully we're getting better. There is one little itty-bitty detail you cannot forget with an inequality, and that is if you divide or multiply when solving. If you divide or multiply by a negative number, you have to flip the inequality. So if the inequality is this way, you've got to flip it this way. If you divide or multiply by a negative number. Do you all understand? You forget to do that and you're wrong. Completely off. So for example, negative 5x is greater than or equal to 15. If I was just to treat that like an equal sign and solve, then what would we do? How do we get x along? Piece by piece. Good. Divide both sides by negative 5. Well, we just divided by a negative. Therefore, yeah, that divides out and becomes 1 times x. But because we divided both sides by a negative, we've got to flip that inequality. So now it is not greater than or equal to, but it's less than or equal to, and that is negative 3. 1 times x is just x, so x is less than or equal to negative 3. Do you all understand? Okay. So here we go. A little bit more advanced problem here. It says, what is the solution of negative 3 times 2x minus 5 plus 1 is greater than or equal to 4? We're going to graph the solution. Remember, we're finding the x values for which makes this statement true. So we're just going to go through and algebraically, piece by piece, solve for x. So looking at this, guys, just treat it like an equal sign for right now, but don't forget if we divide by a negative, we flip the sign. So there are many different ways to solve equations. It's just a preference here. So first step, what would you do? You would distribute this through? That's fine, I can do that. So negative 3 times 2x is negative 6x. Negative 3 times negative 5. Positive 15, and then we have plus 1 is greater than or equal to 4. So really we have negative 6x plus 16 is greater than or equal to 4. Am I correct? Okay, let's move on. What would you do next to get x alone? Subtract 16 from both sides. Do I need to change the sign? No, it's only when multiplying or dividing by a negative. So you tell me negative 6x is greater than or equal to? Negative 12. Then from there, how do we get x along last step? Divide both sides by negative 6, and oh, there's the key. We've got to flip. So we have 1x, and now we have to flip the inequality because we divided by a negative. Less than or equal to what? 2. You're awesome. So really we just have x is less than or equal to 2. There's our answer, but we want to show on a number line what that means. So literally think about it, guys. First of all, we're talking 2 here. We're talking x values less than or equal to 2. So I draw a number line, I draw a straight line, I put in 0, 1, 2. So we're looking at 2 here. Since it's less than or equal to 2, it's definitely equal to 2, so I fill in a closed circle here. Now think about it. X values that are less than that, wouldn't that point this way? Ding, ding. Yeah? Aren't those the x values less than 2? Awesome. Questions? We're all feeling confident? One more example. Okay, what's the solution of -2 times x plus 9 plus 5 is greater than or equal to 3? Once again, first of all, yeah, that's fine. If you want to distribute, I'm okay with that. So -2 times x is -2x. -2 times 9 is -18 plus 5 is greater than or equal to 3. Are we all following me? So we have -2x minus 13 is greater than or equal to 3. Then what will we do? Add 13. So we have -2x is greater than or equal to 16. Divide both sides by -2. We've got to flip our inequality since we divided by a negative. So we have x is less than or equal to -8. Right? Are we all good? So 1, 2, 3, 4, 5, 6, 7, 8. This is in the negative direction. So here's -8. I'm going to graph it. So we want x values less than or equal to -8. So we're definitely landing on -8. The values, x values that are less than that are this way. Are we all okay to do this on our own now? 2 problems for the 10. Okay, so everybody look up here again. For this next part here, we're going to put inequalities into kind of story problems, but really they're not much harder than, a lot of them you actually don't even need to use inequalities, but sometimes inequalities will help you solve an equation or solve what it's asking you. This is very likely something you would see on an ACT test. So it's very good to know. So everybody, let's go through just this example. Now, it's going to be, every problem's a little bit different. So it says, now once again, if you're still working on the worksheet, you will be lost on the next part. And I'm not going to help you because I know this, you know. A digital music service offers two subscription plans. The first has a $9 membership fee and charges $1 per download. The second has a $25 membership fee and charges 50 cents per download. How many songs must you download for the second plan to cost less than the first plan? So that's a lot of information. I'm just going to look at the first piece and write it down. So it says the first plan has a $9 membership fee. So think about it in the real world. If you have to pay a $9 membership fee, then it's $9 right off the bat. Then after that, it's $1 per download. So plus $1 per download. We don't know how many downloads we're talking, right? So we call it X. Does everybody understand how I set up an equation for that first piece?
Yep.
Okay, next one. So this is our first plan. The second plan is, it says a $25 membership fee. So you have to pay $25, and then it's 50 cents, so 0.50 times per download. So that's how much it costs. So that way you could go through and say, like, okay, if I download one, it's going to cost me $10. If I download one, it's going to cost me this, that. All right. So from here it says, how many songs must you download for the second plan to cost less than the first plan? So if the second plan is less than the first plan, wouldn't that be like this? Yeah? And then now can't we just solve for X? Okay. So let's go ahead and do that. So we're doing, obviously, 25 minus 9 from both sides. So we have x, or 1x is greater than 16 plus 0.50x, right? Are we all good here? So we're combining our x's. So subtract 50x, subtract 0.50x. So that's going to be 0.50x's are greater than 16, right? So we'll take 16 divided by 0.50. So x is greater than or just greater than 32 downloads. It will take 32 downloads to actually have this second plan cost us less. So if you're not going to do more than 32 downloads, you should go with plan 1. But if you're going to do 64 downloads, wouldn't you want to go with plan 2? Does that make sense, everybody? So the answer would be 32 downloads. Okay. Everybody, a couple more so that you can get your brain moving in this way. The length of a picture frame is 3 inches greater than the width. The perimeter is less than 52 inches. Describe the dimensions of the frame. So it basically wants us to tell the length and the width. So the length of a picture frame is 3 inches. So length is equal to, oh no, it says it's 3 inches greater than the width. So we don't know the width, let's call it x, but the length is 3 inches greater. So x plus 3. Are we all following what I'm doing? Well, think about it. It says the perimeter is less than 52 inches. So our perimeter is less than 52 inches. So 52 inches though. Okay, so think about it. Perimeter would be length plus the length plus the width, right? Perimeter? Are we all following me?
Oh, yeah.
So we have x plus 3 plus x plus 3 plus x. Right? You get what I'm doing here? Plugging in, the length is x plus 3, the width is x. And it says, oh sorry. The perimeter, so this perimeter is less than 52 inches. Now can we just solve for x? Are we all seeing how to set these up? Do I need to keep going? X plus x plus x plus x. 4x, right? Plus 6 is less than 52, right? Is everybody following me? Do I need to keep going? Can I let you work? So 4x is less than 46. Divide both sides by 4. So 46 divided by 4 is 11.5. So the answer is the width. Okay guys, so stay with me. You wanted to see it. So x is less than 11.5. So this is what our answer would be. Our width is 11.5. Our length is 11.5 plus 3. 14.5. So guys, here's the thing. You're going to do problems 11 through 14. On 12, 13, and 14, I didn't even set up an inequality. I just did it because it was easier to do without an inequality. Does that make sense? So if you can think of a way to do it without an inequality, go for it. Because a lot of them were easier just to do without an inequality. I just did it, did the math. So just get the right answer. But on number 11, you would need to set up an inequality. It's too hard to think of it otherwise. Ready, set, go. So you should be doing up through 14 now. Next piece, pull yourself away from the worksheet and watch, okay? You can always go back during your study hall class or whatever. Alright, so it says it's 4 times 2x, so I'm just going to say it. Is this inequality always, sometimes, or never true? So guys, here's the thing. If you solve the inequality, are you listening? If you solve the inequality and you get a true statement, then it's always true. All real numbers will work. If you solve the inequality and you get some statement that's not true, such as 0 is less than negative 6. That's not true, right? It's greater than negative 6. So that would be an untrue statement. If you get an untrue statement, then there's no solution, meaning it's never true. If you get some expression, x is greater than 2, well, then it's sometimes true. It just depends on what x value you're looking at. Does that make sense, everybody? Okay, so let's go through and do this one. Is this always, sometimes, or never true? So we can do this a couple different ways. Now, I'm going to actually do something a little different this time. Watch this. I'm going to go ahead and say, okay, I have a 4 and I have an 8. They're being multiplied, right? So this is one way of doing it. I'm going to divide right here and right now, divide both sides by 4. So the 4's divide out and become 1, leaving me with 2x minus 3. And I have is less than 2 times x plus 1. 8 divided by 4 is 2. Do you see how I did it? You could have distributed it and done it different. Different ways of solving. Then from there, on the left, I have 2x minus 3 is less than, I'm going to distribute that through, 2x plus 2. Don't forget to distribute that through here as well. So I'm going to subtract 2x from both sides. That gives me 0 minus 3 is less than 0 plus 2. So we have negative 3 is less than 2. Is that a true statement?
No.
Is negative 3 less than 2? Yes, that's a true statement. So it would be always. So that's always true. Are we all good at that?
Yes.
So let's do one more. I'll do this top one. I'm going to go ahead and distribute that negative 6 through. So I have negative 18x Do I not need to do it? Because I won't if I don't need to.
Negative 12.
Do I need to do it or not?
Negative 12.
So,
Negative 12. No.
why are you saying negative? Oh, yeah. True story. Thank you. So we have negative 12x plus 60, right? Plus 12x is less than or equal to 180. From there, I'm going to combine my x's on the left. I have 60 is less than or equal to 180. So 60 is less than or equal to 180. Is that true? Always? Sometimes or never? Never, right? Because of the equal sign? Because it has to be both? So this one would be not a true statement. It's never equal to 180. Does that make sense? But let's say, so I'm not going to do another example, but let's say that we solve this and we got x is greater than 1. This would be considered sometimes, because think about it. If I put a 2 in there, is it true? If I put a negative 3 in there, is it true? No. So with something like this as an answer, we would say sometimes. It just depends on the x value. Does that make sense? True statement, not true statements, easy. Something like this, sometimes, because it just depends on the x values. Do you understand what you're doing?
So the x value, what do you do? Wait.
Like this, if you got this as an answer, Mason, it's not a true or untrue statement, right? But it just depends on which x value you put in, right? To make it true or not. So that's why it's sometimes. Does that make sense?
Yeah.
Okay, good questions. All right, very good. Continue. I need you to do problems 15 through 18 on the back.
How do you know?
Okay, guys, next thing. This is one of the most important things you can get out of today. So we can do inequalities. We learned that many years ago. Today we have to get to compound inequalities. So compound inequalities is when you join two inequalities with the words and or to form a compound inequality. So you're going to have two inequalities, and you're going to solve each of them, and then with and or it depends on what your solution is. So here's a good way to remember it in general. And means picky. So and means intersection. So if you're a picky person, like for example, if I said for Christmas, I want a car, and I want a boat, and I want a trailer, then I'm pretty picky, right? I'm not giving any options. I'm just giving a bunch of ands. But if you're saying or, so I want a boat or a trailer or a ski, I don't know. Do you get what I'm saying? Or you're not picky, right? You're giving options. So that's just an easy way to remember. And is picky. It's only where you want everything at the same time. And or is either or. Okay? So looking at this with and, you're gonna solve the inequality. So we have this inequality. So I'm showing you this so we can get through this quickly. So I've already done the work, so I need you to just look with me quickly. Here's this inequality. If I went through and solved that inequality, I get 3 is less than x. Does everybody understand what I did there?
Yeah.
So then I have the second inequality. And I still go through and solve it, I get x is less than or equal to 6. Well, because of the and, it's very picky. So we only want it if it's less than or equal, less than 3, and at the exact same time, greater than 3, and less than or equal to 6. So I graph each of those. So I graph the x is greater than 3, which is right here. Right here, x is greater than 3. So I graph that. Then I graph x is less than or equal to 6. So I go and graph that. Now we only want where those two places intersect. So do you see how right here is where they intersect? Yeah? Where they're crossing. Are we all good? So this is all you would fill in for the number line. That's your answers. 3 up to 6, including 6 but not including 3. It's picky, only where it's full. Does that make sense? Are we all good? So or, the difference between and or is friendly. Either or get to come into our answer. So the and is the intersection of them both. That's where it intersects. That's the only part of the answer that gets to come. It's picky. Or is either or get to come. So I solve each of them, graph it, and either or get to be in our solution. So this would be on our number line, and this would be on our number line. Is everybody okay with that? And versus or. I'm not sure, because you're all just staring at me.
Yep.
Good.
Okay, so do you need me to do one?
Yep.
Yeah.
Okay, So we have 3x is greater than negative 6, and at the same time, 2x is less than 6. So this is a compound inequality. And is picky. I'm just going to first solve them individually. Divide both sides by 3. X is greater than negative 2, right? So that's going to be on our number line. So I draw my number line. Well, I'll just solve this one first. Divide both sides by 2. X also has to be less than 3 at the same time. And. So I'm just going to graph them individually in purple. Why not? So if we have a number line and we have x is greater than negative 2, here's negative 2, and I'm going to have an open circle and it's going to be this way, right? Now I'm going to, I guess, do a different color. Why not? And also x value is less than 3. 1, 2, 3. So x value is less than 3. Well, the only place that they intersect is right there. So that's my answer. So I could write it like this. Our x values are greater than negative 2. So our x values are greater than negative 2 and less than 3. So these, you could just write your answer on a number line. I'll accept that. So this is how you'd write it by hand. But it's easy to do it using your number line. Do you all see what I did there? Do you understand how it was picky? Okay. Do I need to do an or one?
No.
You're sure. So or, let's say that I change this to or. Wouldn't that be all real numbers? Because it goes forever this way and forever this way, and they don't have to intersect. It's anything, either or gets to come. Do you get what I'm saying? Okay. So, I won't do that. Do problems 15 through 18. That's all. Sorry, not 15 through 18. I mean 19. Oh. 19 through 24. And that's what's due by tomorrow. 19 through 24. So I just did 19 for you. Okay, 22 on the worksheet. If you don't want to listen, that's fine. So we're asked to find, we're doing this compound inequality. So 6x is less than negative 12, or 5x is greater than 5. So you just solve individually. So I have x is less than negative 2, and then I solve this one, and x is greater than 1. So now, or is friendly, either or gets to come on our number line. That's all part of the answer. So if this is 0, 1, 2, negative 1, negative 2. So I'm going to just graph them individually. So x is less than negative 2. So less than, open circle, this way. That gets to stay in our answer for sure. Either or means either solution gets to come. And then x is greater than 1. So greater than 1 would be this way. So with this one, they would keep both for our answers. Because or is friendly. Either or gets to come. And is picky. Only the intersection where both things are happening at the exact same time get to come into our answer. So is everybody good? Are you feeling a little bit more comfortable with and versus or? Okay, awesome. So yeah, all that's due is up through 24 tomorrow, and then the rest we're not going to do.
What?